Welcome to Making Stuff with Chris Dayhut and our segment titled This Maker's Tools. For today's exploration, we are going to take a look at a 3D printer. Now, you might not think of it as a tool, but truthfully it is, and it fits into the category of a machine tool. Now, unless you've been living under a rock, most likely you've heard about these and seen them perhaps, and most likely you already own them. So this video is more for people thinking about getting into a 3D printer. So this will give you a different perspective on how they're used. Now during this video, up over here, I'm going to have a 3D print going on for the entire duration. So it'll take you from start to finish of this machine, 3D printing a very useful object. It's ultimately an additional clip for my wireless microphone. As you may already be aware, there are many different types of 3D printers or processes called 3D printing. For the purposes of this video, we are referring to a machine that performs fused deposition modeling, also known as filament printers. This is a process where a thermoplastic filament is heated and extruded through a nozzle, and the material is deposited on a build plate, allowing you to print three-dimensional plastic objects. And this process happens by printing layer after layer after layer. The original purpose was for rapid prototyping, where you can take a 3D CAD file and create a physical model of it very quickly. They are often used to make three-dimensional objects that would be extremely difficult or even impossible by other means. The objects can be pre-designed models that you obtain by getting the digital file of something and then processing that into a three-dimensional physical object. They are used by hobbyists for many purposes and also in manufacturing to 3D print more advanced materials into highly complex shapes. "3D printing brought about an entirely new process for creating objects, or manufacturing, if you will. It is an additive process wherein the object is created from raw material being fused and deposited in the shape you desire. You're adding material to build something, as opposed to the alternative process called a subtractive process. A subtractive process is wherein you start with a solid block of material and remove everything you don't want, ultimately creating a lot of waste or wasting a lot of material. Pretty much in most industries, that material can be reclaimed, but there's a lot of it that just ends up in the landfills. Furthermore, you can take the 3D digital model and easily process that into a real model in a wide variety of materials. "3D printers are just about everywhere things are being made." During development, there were two parallel channels of development: personal use and industrial use. Both markets have huge potential and are thriving to this day. Both markets are experiencing continuous growth, and there is no slowdown seen in the future. Just as the case as where 3D printers are used, the people using them range from hobbyists at home that want to print and make 3D objects for a wide variety of uses, within industrial applications to make tooling to aid other forms of processing, and of making actual 3D printed metal parts to create highly complex shapes that are too difficult or impossible to make with traditional subtractive processes. These 3D metal printed components often find their way into aerospace applications or in high temperature applications, and they are often made of very hard and tough materials such as stainless steel, Inconel, and Monel. Many people's first experience or exposure to 3D printers was seeing something in the form of a cute little trinket such as this that was printed on a 3D printer. Now, you won't see much of that in the industrial world, but in the hobbyist world, it probably accounts for more than half of the primary use for 3D printers. In the hobbyist market, some people print pre-engineered models that are for practical purposes as well. Other hobbyists, such as myself, we use the 3D printer for the purpose of creating something that we have actually taken the time to design and engineer using CAD software. That's a really great purpose and application, especially if you look at the 3D printer as a tool. The industrial applications are far more biased toward making highly complex shapes that cannot be made through a subtractive process. It is also very slow by comparison to printing with thermoplastic filaments and even some resins. The process for most industrial applications to make 3D metal printed parts is you lay down a layer of powdered metal on the build plate. Then you take a laser and you harden all the little bits and particles of metal that you want for that layer. Then you spread down another fine layer of metal powder and take that laser and sinter that layer. And you just keep repeating this process until it's entirely complete. In order to appreciate the current state of where 3D printing is, I find it very important to look back at the history of it. In 1945, this is around World War II, the concept of 3D printing was realized in the short story Things Pass by author Murray Leinster. In 1971, Raymond F. Jones patented the liquid metal recorder, a continuous inkjet printing process. And I assume that means something very similar to what we're doing with filament, plastic filament, but with a liquid material. The liquid is put down. It is either allowed to dry or forced to dry by using UV light or heat or some other means, and then just keep printing layers and layers of that. The first commercial 3D printer, the SLA-1, was developed by Charles Hull and released by his company, 3D Systems, in either 1987 or 1988, as I couldn't quite get clarification on which year. This printer utilized the stereolithography process, where layers of photopolymer resin are cured by a UV laser to build a 3D object. Hull's invention revolutionized the manufacturing industry by enabling rapid prototyping and the creation of complex parts layer by layer. So as you can see, there was actually a drive in the industrial world to create 3D printers long before there was the drive to create them in the hobbyist or consumer market. In the early 2000s, Adrian Bowyer started a project called RepRap, standing for Replicating Rapid Prototyper. And this was very instrumental in the entire movement of 3D printing for consumers and hobbyists. This project really laid a lot of groundwork in the development of very economical 3D printers. The whole project was an open source community project that drove a lot of early development and really pushed that idea of 3D printing and in the construction thereof 3D printers for the DIY type people. A lot of their efforts were in the fused deposition modeling process. In 2009, the patents expired for the fused deposition modeling printing process. And with that, it opened up the floodgates of a massive amount of investment by manufacturers and hobbyists and consumers to build and sell FDM-style 3D printers, which you see everywhere in the market today. I've put some links down below in the description that can take you to more information about the historical origins of 3D printing. Sooner or later, we got to have the discussion about how much do 3D printers cost. And in reality, I think it's how much are you willing to spend is how much they cost. Let's take a look at a few websites showing you the range, so to speak. Here on the world's marketplace, also known as Amazon, they're listing a 3D printer, this little guy, as a user-friendly entry-leveled for enthusiasts and educational purposes with integrated software. I wouldn't expect this to be a real high-performance printer, but I am quite certain it will actually 3D print objects for the whopping cost of $92.98 plus $2 delivery. Not a lot of details about it, but enough to get me convinced it might actually work. So my thinking is somewhere around $100 is at the bottom end of the market, which is remarkable for what it is actually capable of doing. At the higher end of the spectrum is this particular 3D printer, which I found by sorting out the list of 3D printers, starting with the most expensive first. And you can see the price is very high at $19,999, and it does have quite a bit of build volume to it. They refer to it as a large-scale 3D printer with dual independent extruders with a build volume of 600 by 600 by 800 millimeters, which is approximately 2 feet by 2 feet by 2.5 feet. The nozzle goes up to 300 degrees Celsius, so it can handle a lot of the different varieties of plastics, and it has a touchscreen control on it. And beyond that, it doesn't have a whole lot more information to convince me to buy it, especially at the price of $20,000 US, but it does offer free delivery. So that's kind of your consumer market range. Now, I will say that $20,000 printer is probably more for manufacturers or companies, because it's hard to justify that price for the hobbyist or consumer. Now let's take an even bigger leap forward or up in the price scale. At the opposite end of the spectrum is this particular machine from DMG Mori. They manufacture and sell CNC machine tools and additive processing type machines, such as this SLM machine, which is selective laser melting, also called selective laser sintering. Now you'll notice that it's got a relatively small build plate, at least small to the large scale one we just looked at for $20,000. You'll notice that it is 12 inches by 15 inches on Z. And it has a minimum layer thickness, which is really critical in the industrial world, of 0.0012 inches. So 1/1000 and 2/10 if you're using machinist speak. It's take a piece of paper, slice it into thirds, and that's about what that size or thickness is. And then the minimum focus diameter is 0.003 of an inch in diameter, which would be the laser, sintering laser that they're using to melt the metal and fuse it. It's 600 watts in output power. Now, I don't have a price right now. I will try to obtain a price for this machine before I release the video. So hopefully it'll appear somewhere here as a pop-up or something like that. I suspect at this time, I'm going to guess it's at $1 million, maybe as much as $1.5 million. But we'll see. Hopefully I can get you some accurate information on that. But overall, the price of 3D printers runs the full range, and it really depends on what you're demanding from that printer. Here are a few brand names that have been in the game for quite a while. Creality, Anycubic, Prusa, Bamboo Labs, and Flash Forge. My current 3D printer is the Bamboo Labs X1 Carbon with the AMS multicolor attachment that allows me to print in up to 4 colors automatically on the same object. Don't use it all the time, but it is a great feature to have. This particular printer has been very reliable in the process of 3D printing. I rarely have the failed 3D prints and so on. It is very accurate. Most of my prints are very close to size, well within expected tolerances that you would get from FDM type 3D printing. The machine itself is very good quality. It is not like a lot of the other imported 3D printers that are of very low cost. Now, of course, you're paying a much higher price for this printer, but it is yielding exceptional value for that particular price range. And it also has a pretty decent sized build volume that works well for a lot of the hobbyist and consumer markets. The price for the X1 Carbon 3D printer with the multicolor attachment is right around $1,500. Yes, it sounds like a lot of money to invest in a 3D printer, but you can also justify that price by the value it brings in quality and reliability, as well as overall usability. So I've been pretty well happy with this choice and have no plans on getting rid of it anytime soon. Now, how people use 3D printers varies a lot. We talked about hobbyists who like to take and download little 3D models of trinkets, such as my little helmet guy, and they print those, all kinds of gaming pieces and cool little sculptural items, and a lot of those are then further refined with very highly detailed painting and all of that. And that's a great and wonderful application and hobby. There are the people that are more practical minded, such as myself, who focus more on practical uses for it, and then the occasional trinket to keep it fun. And then the next level up are the people that want to engineer something from nothing, design it, engineer it, 3D model it, and then print it, and then perhaps make something else out of it. And here are some examples of the things that I've been making with my 3D printers during the last 10 or so years. Everything from simple battery holders to brackets to here's a camera, a digital camera that I designed and built. It's still a very great project I did perhaps a couple, 3 years ago. Just an awesome project. Here is a 3D printed housing or case for antique style radio that I designed and built and featured here on the YouTube channel. But it just runs the full range of what you can expect to make, and as long as you keep your design and engineering within the usable properties of the material, such as PLA, a very common printing filament, to ABS, which is a tougher material, but it really kind of stinks because it's polystyrene, so you have to be careful using it indoors and things of that nature. Bearings, sleeve-type bearings can be made with it by printing out of nylon. So people use 3D printers for a wide variety of applications, but it does seem to be pretty well split between artistic objects and creation, practical items, and those that are engineering something and utilize 3D printing or the additive process to create that object. The alternative would be to try to assemble or create some of these things from solid material, removing the material that you don't want, or assembling it from many little pieces that you've hand-shaped and hand-carved into one larger component. Now this camera, for example, realistically, I would have probably never even attempted it if I was working with any other process other than 3D printing. With that, hopefully you become a little more aware of the massive industry that 3D printing is. For consumers, hobbyists, and industrial manufacturing, it is a very ingrained process of manufacturing and making components in our society today. I was very reluctant to get into 3D printing. I've got 45 to 50 years of fabricating stuff from existing materials, taking something, bending it, melting it, shaping it, gluing pieces together, all of that to get some object or device. The whole process of creating for 3D printing is a very different process from creating something that you're going to assemble from miscellaneous components or a solid block of material. So the additive process, 3D printing, and the subtractive process really plays strongly within your design and engineering stage of object creation. So with that, I'm going to wrap up this video. Thanks so much for watching, and I look forward to seeing you in the next video.
And he thinks it better even now. Wonder where she's